Craig Uranek here, and we're covering the first part of section 4.5, using exponential functions to model data. And again, this is what the pattern of the book is. We come up with data, we try to match it to a curve. Once we can match it to a curve, which in this case is going to be an exponential function, then we find the equation so we can make predictions and estimates. So with that in mind, let's go to example 1. Example 1 is modeling with an exponential function. You can see that it says, suppose that a peach has 3 million bacteria on it at noon on Monday, and that one bacterium divides into 2, so that's the rate that it's multiplying, or the base multiplier, every hour on average. And they give you a picture there. And then down below says, let B be f of t, be the number of bacteria in millions on a peach after t hours afternoon on Monday. Find the equation of f. So again, we're using exponential functions. So we're using f of t because that's the format they wanted, equals the y-intercept times the base multiplier raised to the t, where t is the time in whatever units they're using. Well, the y-intercept is always the initial position. And the initial position was at noon on Monday. And on noon Monday, there were 3 million bacteria. So the time is noon Monday. The amount is 3 million. So A would be 3 million. Then the multiplier is that it divides, so it doubles, in other words. That sounds like half as much, but notice you start with 1, then you have 2, then you have 4. So it's doubling every hour on average. So again, our time unit is hours, not days or years, but it's hours, and it's doubling. So that would be 2 to the t. Ordinarily, they'll put in parentheses. So that would be our equation. And then 2 says predict the number of bacteria on the peach at noon on Tuesday. So if we started noon Monday and we went to noon on Tuesday, that would be 24 hours. And so therefore, to find part 2, this is part 1, to find part 2, we find f of 24, which equals 3 times 2 to the 24th. And this will be in millions, notice, of bacteria. So let's go ahead and get our calculator out. I think that's fit fine. And so I can just turn it on, and I'll just clear this. So we have 3 times 2 raised to the 24. So we end up with that many million. 503,316,48 million. And of course we would want to put commas. You could either put it that way or you could add 6 zeros. So there's example 1.